Hello everyone, this is a quick video on how to implement a coefficient of variance in the NIRS Toolbox or Brain Analyzer toolbox. If you've ever used NIRS Lab, there's a step called data quality check or check data quality. It basically implements a very quick and easy to use coefficient of variance across all data sets, or excuse me, across all channels for a single subject. It is incredibly fantastic and wonderful, but once you get into using it for multiple subjects, it can be a little bit tedious. Therefore, you may be moving into the NIRS Toolbox, among other reasons, for several uses of the NIRS Toolbox. In order to actually move this function over, you will actually have to use an inline script, but I would like to give you just a little background on kind of why you would want to use this and what it's actually telling you. So any measurement you make will incorporate both signal and noise, signal being the thing that you're actually wanting to measure and noise being anything else. The big question that comes up is how noisy is my data? How reliable is it? And a common way to actually determine this is using the coefficient of variance or CV ratio. The formula is incredibly simple. You're basically going to calculate the mean of your measurement, and you're going to find the standard deviation from that mean, and then you take that standard deviation and you divide it by the mean. It's incredibly easy to calculate and it's very useful, but the idea is that if you have a very good data set or something that is much more signal than noise, it would vary very little from the mean. The mean should represent the signal itself quite well. But if you have a very noisy data set, that standard deviation would be wildly different from the mean, or very large in comparison to the mean. So therefore, the larger the value, the more noise there is assumed in your data. If you want to calculate this in the toolbox, it's actually, I haven't found a function in it. There are probably pushing 1,000 functions within the toolbox, so I'm not saying that it's not there, but in digging through all of them so far, I haven't found one that seems to calculate this. So you'll probably actually have to write your own script for this, and this video will actually show you a script that should work. This will assume that your data set contains multiple subjects, and then we'll have some for loops for each subject. If you have a single subject, you can probably just remove the for loop and therefore the index that's used in the for loop. The first step you're going to want to do, regardless, is actually trim your data. The reason for this is that you probably started your measurement far before your experiment, or at least a little bit before you started your experiment, and the subject could have been moving around. You could have been explaining directions, scratching their head, doing several other things that could have led to quite a bit of noise at the start of the measurement, therefore impacting this coefficient of variance ratio. At the end of the study, there's a good chance that perhaps you took the cap off before you turned your system off or stopped your measurement. And in that case, the standard deviation would vary rapidly as well. So both of those scenarios would impact this coefficient of variance ratio drastically, and you don't want, and it's not actually true. During the experiment, you actually had very good data. So you want to trim that out, and this trim baseline function in the toolbox works wonderfully for that. Basically, it's in the NIRS folder under the modules subfolder, and it's called trim baseline. You create it as an empty job, as J is the standard, and it has two properties in it. One is pre-baseline, one is post-baseline. They're defaulted to 30. You can change it, as I showed here, to 10 and 30. You at least want 5 or 10 seconds at the start of your experiment so you can extract a baseline for any block averages or anything like that. And you want probably 30 seconds after to ensure that your signal dropped back to baseline at the end. In order to run this, you're just going to select j.run or your variable name .run and select it on your data. In this case, our data is called raw. I always output it as a new variable. That way I don't impact my initial data set. In this case, I call it raw trim because I trimmed it, but you don't have to. You can move around this however you feel necessary. If you have multiple subjects, you will need that for loop, as I mentioned. Not for this trim baseline. This will actually do it for all data sets, but for our coefficient of variance measure in a second. In order to do this for loop, you will need to know how many subjects you have. So this line of code will actually calculate that for you. Get the length of your data variable. You can also do size variable and then select the dimension, which in this case would be columns, which would be dimension 2. So you can do size, parentheses, raw, comma 2, and that would actually output the same information. The code that will actually calculate the coefficient of variance is this. First, we create an empty variable called subject CV, CV. Next, we're actually going to go subject by subject, and we're going to fill this subject CV in. The first thing you do is actually extract the data for that specific subject, here denoted by I in this loop. Next, we get the dimensions of that data. We create a zero matrix, just a matrix filled with zeros. That's going to be however many columns that subject has, so however many channels that they have. You go through each channel, you calculate the mean, create a matrix for that, which is here. You create the standard deviation, create a matrix for that. Both of these should actually have the same dimensions because they're the same channels. Then you create a CV matrix, which is going to be the standard deviation divided by the mean of the signal for each channel. And that's what that dot denotes, is that you're going to go channel by channel, item by item. Once you come out of that, this CV mat will actually become the row for that subject CV. So each subject gets their own row, and each row will have columns for the number of channels that were included. If the subjects don't have the same amount of channels, this becomes a problem. So it's a matrix. It's going to expect that everything is the same in dimension. If it's not, it will call an error. So if that's the case, you may want to rethink how you do this, but for this scenario, it should work fine. Next, you'd probably want to plot it. In order to do that, we're going to select the rows and columns from this matrix, get the size of it. We're going to select a threshold. In this case, it's 15%, 0.15. Another standard a little bit more aggressive is 7.5%, 0.075. That's pretty aggressive. It may be overkill, but it's quite good as well. And then we're going to create a line that we're going to draw on a graph here. So here we just create a series of rows a series of ones that will be multiplied by this value. And then we plot the figure below here. So this is what it would look like. Just to show you, I have 11 subjects here. The majority of them are quite nice data sets, but you'll see especially here's my threshold at 15% in this blue line. Subject 11 has a lot of channels that are very bad. So subject 11, a lot of noise going on. Subject 10 has a few. Subject 9 looks like they have one. Subject 8 has one. Subject 4 has a few. The rest of them are actually quite good. They're under 10%. Look good. So this is just visually, it will actually give you an idea of what your subjects look like and everything. You probably want to do something with this information. Here is just a suggestion on how to correct it. I'm not saying this is the best way, but what I did is just replace all bad channels with zeros. And these zeros would essentially eliminate any sort of statistics that you run on that. The problem is you could actually, the statistics that you run on it actually may cause errors depending on how you run it in the toolbox. So this may not be the best way to do it. But the idea is basically that if the subject CV at that channel for that subject is above that threshold, you're going to turn every single value in that channel for that subject to 0. So basically that channel is zeroed out. The idea that I had behind this is that I'd use this as a labeling mechanism. So instead of taking out channels, which could again cause formatting issues in the toolbox, and I'm sure there are ways around that, but I have not figured that out. I wanted to just tag them. So I tagged them by setting them all to 0 and finding the channels that had a sum of 0. That's a suggestion. I don't think that is the best way to go about it. I'm sure there's better ways to go about that. One way I thought about is actually going to be labeling the bad channels. So just kind of how I did, but in perhaps a different way. You find all the channels that go past this value, you extract the channel numbers for those subjects, you run all the statistics, and you look at those specific channels, you just take them out of the statistical measurements. Maybe that's the way you want to go about it. Again, I'm not necessarily supplying you with the correct way to do it, just some suggestions on what could be options. I hope this is helpful. It's a pretty simple script on how you can run this in the toolbox. There are several other ways to go about this, but this is a fairly easily understood and easy way to go about it as far as determining your data quality. Anyway, I do hope that was helpful and have a few more videos coming up. Thank you.